All right. Good afternoon, everyone. Welcome to our April edition of ITS Michigan's webinar series. And today we have a very amazing and interesting topic to share with you, discussing the present and future of cloud-based smart cities. And in order to bring that topic together, we reached out to two very seasoned companies and being represented by three very seasoned professionals in the realms of Miovision Traffic Cloud platform from the Miovision side and the Amazon Web Services platform from the Amazon side. So our three speakers are going to be in no direct order: Phil Silver from Amazon, and Kyle and Brent, Kyle Othmer and Brent Rogerson from Miovision. I do want to point out that our landing page, our website is itsmichigan.org. Please feel free to visit us there periodically and sign up for our mailer so you can receive all the information from us. I do also want to point out that we are available on different social media platforms, mostly LinkedIn and Twitter. Please do follow us so you can get all the latest information pertaining to our chapter. With that said, I'd like to kind of give you a little bit more of an overview of the presentation itself. And instead of showing the solutions on either side when I'm talking about the webinar today, I thought I'd show the problems. And I used a couple of pictures from the city of Detroit to kind of reiterate the abstract that we're going to be covering today. So the Miovision platform that is being used by the city of Detroit is powered by AWS cloud computing, and it allows us for ongoing data access and continuous value added to develop and grow the agency needs that we have as a city of Detroit. So although I'm not speaking today, I'm proud to say that I've worked with both agencies, and I'm going to let them kind of present some of the solutions that they have for agencies and cities and DOTs that are involved with transportation engineering. This presentation, though, will provide an overview of the Miovision platform, highlighting the City of Detroit's network of connected intersections. Miovision will provide a dive into the traffic ITS data produced from each intersection and walk us through how data is turned into actionable insights for citizen impacts today and in the future. And at that point, AWS is going to take the conversation over to provide an overview of their platform and solutions that make it possible for smart city solutions, such as Miovision and other technology companies, to exist, grow, and provide powerful services to transportation agencies. And from the city's perspective, we're always looking for high quality detection, intersection monitoring, intersection performance, network performance, and IoT devices and cloud performance, all being done real time, very little downtime, et cetera, et cetera. So I'm hoping that today's discussion is going to maybe trigger a few good questions. So if you have any questions, feel free to type them in the chat box, or you can hold them off. We've kind of earmarked about 15 minutes at the end of this session for your questions. And introducing our discussion panel here today, I'm going to start with Brent Rogerson. He's at Miovision and heads the ITS sales engineering group for the City of Detroit group. And Brent brings a wealth of experience in the traffic industry and various other industries. Brent is focused on the desired outcomes of Miovision's largest agencies, customer life, and accounts growth. In his 12+ years with Miovision, Brent has developed a deep understanding of Miovision products, giving him a unique user perspective, which enables him to be a strong voice for the customer. Prior to Miovision, Brent had roles in roads operations at local municipality level. I'd also like to introduce Kyle Othmer, who is the Director of Strategic Accounts with Miovision as well. Kyle Othmer is the Strategic Accounts Director for Miovision. He has spent the past 10 years navigating the intricacies of the transportation industry, honing his experience in the advanced traffic data solution space. Kyle is passionate about empowering transportation professionals with the data, tools, and insights they need to improve their citizens' mobility experience. And of course, these two gentlemen I interact with quite often. The third gentleman, who again I have had the privilege of meeting, Phil Silver, although I don't do direct work with him, the entire platform that Miovision lives on or that cloud platform, it comes from within that service, which is AWS. And Phil Silver is the leader in transportation, state, and local government, and the worldwide sector with AWS. So Phil leads AWS state and local government transportation vehicles, including activities with airports, seaports, transit agencies, toll authorities, traffic departments, parking, Department of Transportation, and regional planning organizations. Over the past 20 years, Phil held sales and strategy leadership roles in global systems integration firms who are specialists in payments, traffic management, tolling, parking, IoT, and advanced analytics. Phil served in the U.S. Navy, capping a 25-year active duty and reserve career with command of 2 expeditionary welfare units that deployed overseas in support of our naval forces, retiring as a captain. But this is the interesting part here. Like every paragraph is super interesting. Just getting to the third one, which is also very much related to what we're doing here today. Phil serves on the board of directors of the Intelligent Transportation Society of America, here in the Masters in Executive Leadership from University of San Diego, an MBA from Fordham University, and bachelor degree in chemistry and history from University of Florida. With that said, I want to welcome all our panelists. I'm going to stop presenting at this point and then pass it along to Miovision so that they can start providing us with their overview of the system that they're providing. Brent?
Great, thanks, Tony. I'll just share this. I think that's working.
Looks good. Yeah, thank you, Tony. Thanks, Brent. Thanks for the warm introductions as well, Tony. And thank you to everyone for allowing us this venue to kind of present our solution and talk through what we've done for the city of Detroit. It's very much appreciated. So thank you to all. Let me just start by kind of identifying who Miovision is and where we're from. We are a company located in Waterloo, Ontario, about an hour west of the city of Toronto. In the Waterloo region, we host a university called the University of Waterloo, very well known for its computer engineering, computer science engineering programs. Out of this university spawned an array of tech companies. One most notable, Research in Motion, or BlackBerry, the rise and fall of BlackBerry, as many of you know. But the blessing there was it allowed for a ton of software engineers and skill sets in our home market, which we've hired an array of. Fast forward to today, the region of Waterloo hosts an array of different tech companies, from Google, Spotify, Desire to Learn. There is a big chunk of tech companies in our hometown, which provides a ton of talent for software engineers. So yeah, that's where we came from. Today we have about 250 employees. We sell across the world, most notable in North America, United States and Canada are kind of our prime markets. Yeah, so again, thank you all. Just to give you a quick overview of what we're going to talk about today, we're going to quickly go through our hardware, identify what it is and how we use it. We're then going to go into kind of how we do detection and how we do traffic counts permanently at the intersection. We're then going to unwrap some use cases in the city of Detroit around intersection monitoring and performance, network reporting, performance and safety, as well as the IoT gateway, IoT devices, and the cloud platform, which will pass the puck over to Phil. So yeah, let's get going here, Brent. Yeah, just to start with a simplistic overview of our hardware. As you can see on the right, there's three devices, four including the antenna. I'll start with the device on the left called the Miovision SmartLink. This is a secure LTE modem and cabinet integration device. The most simplistic way of identifying this piece of hardware is it's a data aggregator, an open device, open IoT / managed switch device. So any speeds and feeds coming off of the controller, the cabinet, the MMU, the intersection, existing detection is all hubbed, stored in this device, sent to the cloud, and then allows for Miovision to plug it into our analytical software. So it does have a 4G LTE modem to provide, out-of-the-box communications. It also incorporates a travel time probe to give you visibility into travel time patterns within your network, as well as a GPS time sync to retime those or resync those controllers when they do start to drift. So yeah, it is a fantastic tool, and it can be purchased separately outside of the other devices. This can be an independent device, just providing communications and an out-of-the-box signal performance measure platform. We can go into that a little bit further. If I move along to the Miovision Smart View 360 camera, again, this is a heated camera to allow for a heat shield for within Canada. We have all types of hot days when snow melts, when ice melts, when icicles form. We have built this device to be interoperable for all types of weather conditions. We do not actually have a blind spot in our 360 camera, where you will see in other 360 cameras there is a blind spot underneath. We've been able to do that with a really nice tilt and tilt functionality of the camera to give that full view. And obviously the out-of-the-box experience is pretty great with Miovision. We incorporate mounts, cables, brackets, and everything that is required to deploy that camera at the intersection. So yeah, that's our Miovision 360 camera. If you look to the far right, that's what we identify as the Miovision SmartSense device, basically the brains of our roadside computing. Within this device, you'll have 2 GPU chips. They're actually called TX2 NVIDIA chips. NVIDIA, well-known computing chip manufacturer out of California. We've embedded those directly into the SmartSense. And yeah, currently, based on our analytical power, we're only using one of those computing chips. It allows for more room as we expand our capabilities with computer vision. 64 detection outputs, 64 SDLC, 4 Ethernet ports, and 2 power over Ethernet ports, allowing for plugins of third-party cameras or whatever else you may want to extract out of that cabinet and controller we can plug into. And again, an LCD live status and diagnostics tool to allow you to do roadside configuration and roadside setup. So yeah, I won't get into much more details in regards to the hardware, but yeah, that's just a quick simplistic overview of the hardware. I'm going to now pass the presentation over to Brent Rogerson, Miovision Solutions Engineer, but will be on the line for commentary and comments. Thanks, Brent.
Awesome. Thanks, Kyle. Thanks, everyone. Excited to be here. So I'll kind of take you through the platform side of this. This is bringing us a little bit up into the cloud mentality now, and what the hardware that Kyle was describing at the side of the road, what that really means towards data and operations. It's the most powerful device at the side of the road, and it does enable a lot of applications along the way. So right before I get into that, the applications I'll cover is following that agenda a little bit. We'll go through the detection and counts that are provided from those devices. We'll go through the signal management features, and then all of the signal performance measures and all the data that comes along with the platform. So I'll kind of take you through that. I do recognize that there will be quite a bit to digest in this, so I won't go too deep into every topic. If you want a follow-up kind of webinar or a deep dive into the features, I'd be happy to provide that following this, but I'll kind of give you the highlights along the way of what the platform can provide and the power of the cloud platform that we're operating on. So first, the detection and counts. So really what is powered at the roadside from those devices. This is a full detection and count product. So we can run, as you can see there on the right, we can do all of the detection for actuation, multiple lanes, up to 64 channels, as Kyle was saying. What this lets us do is identify all the objects in the cars, between cars, trucks, bikes, pedestrians, all at once and in a high-powered format. So you can see kind of on the bottom right there, somewhat of how much it's capable of doing all at the same time. And I'll have a better image of this in a second. But all at the same time with those graphic processor units at the side of the road, we can detect, place occupancy calls, count, classify all at the same time, all in real time, really quickly. And we're just scratching the surface of the real applications here. And it's a 24/7 application that allows us to continuously count and operate at the roadside and stream a very high quality amount of data to our cloud platform so that we can turn that into some great insights. Just to reiterate that point of detecting high volume and high complexity intersections, this is somewhat looking a little bit behind the scenes of the trajectories and the individual objects. So you can see we're tracking where they are, where they're going, how many, all within the frame, and then waiting for those to turn into movements and actual behaviors at the intersection, and then we can turn that into data that I'll show in a second. But the main point here is that having the horsepower at the intersection to collect the right data will allow you to then turn that into the right outputs or the right actions to create citizen impacts. If you have a good view of what's happening at the intersection and you have the right level of data, then you can start making some of the best decisions from that as well. This turns into our continuous count program, where we have a platform between Trafficlink and DataLink, where some of you may have heard of our Scout product, where we actually process about 60% of all turning movement counts in North America today. Our SmartSense product is very much the same concept, where it's just doing it 365, 24/7 in a way that we're collecting all of those classifications all in real time and using the power of what we've learned over the last 15 years about turning movement counts to turn that into useful reports and trend calculations that you can use over time. So that's looking at the detection inputs and the counts that the system is providing. While we are connected for the purposes of detection, we're also connected for the purposes of the controller integration and the overall monitoring of that signal operation. So in the city of Detroit, we actually have close to 400 and we have about 471 intersections installed now with a large range of cameras and detection. We're actually closer to 200 here now. So this has jumped up a lot in the last little bit, but you can see on the map view here that part of it, managing all of the individual nodes on a map or managing all the detection products, is also connecting in each one of the intersection in a layout that you can manage an entire ITS network on, connecting controllers, connecting our detection product, connecting those controllers for the purposes of timing plan management, as well as integrating that network and our cloud network into the city central management systems like Centrax or Tactics or whatever tool may be used. So the power of the platform in the cloud allows you to connect all of these individual points up to that cloud platform, where you can constantly stream and utilize each one of those connections individually. From there, with the connection of our product into the cabinet, you get real-time monitoring and real-time remote access to each one of those intersections. So you can see the signal state, you can get alerts based on that, you can understand what is happening in my network, where are all the problems, and where are the critical issues that we really need to dive into and resolve and understand further, so that the city of Detroit can deploy their technicians to go out and resolve them even before they become citizen complaints and be ahead of everybody in that sense. To build on top of that, we also have the cabinet remote access. So you can actually remotely access all of the devices in the cabinet. So you can do quite a bit of remote troubleshooting even before somebody arrives on site. This way you have full eyes on your entire network and you can understand exactly what needs to be done on any given day. From each intersection level, so that's looking at a network level, but at an intersection level, because we are connected in, we get a full live and historical view of the telemetry. So we can see the phasing, the pedestrian signals, preemption, all of the detector hits, live and historical, and outlaid on the map there, so that we can see exactly what's happening at the intersection and even investigate citizen complaints if, say, the intersection didn't do something as expected or whatever it may be. So with all of that connected, having access to the cabinet, having all of the detection input, this brings us to a level of data that's just incredible. It's the right visibility, it's the right high-res level of data between the controller, the detection, the counts, and all of the inputs that we have. This really allows us to turn it into a full network performance platform. So the way we tackle this and the way we are really adopting the ATSPM concept, so the automated traffic signal performance measures, is really to tackle the the difference in mentality between what the FHWA recommends of retiming a signal every 3 years to applying a more iterative approach to managing the signal, so that you don't have to really revisit every intersection every 3 years. You have constant feed of data, you have a constant understanding of what's happening in that network, and creating an iterative approach to managing the signal, so that the amount of delay that goes into making improvements is not waiting every 3 years. It's happening all the time and always, using the tools that provide up the right data sets at the right time to make an action out of it. So significantly reduces that delay to action, which we like to constantly accelerate through building and constantly improving our tools for city agencies. Going to the signal performance side, we have all of the performance measures. I'm not going to hit on each one of these, but if you're familiar with all of the standard performance measures, they're all built directly into our platform, between travel time metrics, which come from that Wi-Fi travel time probe in our antenna, detection for occupancy, so the stop bar detection, advanced detection upstream, all of the controller operations, including phase intervals and so on, and then turning that into even things like safety and progression data, so that we can really get some actionable insights out of that. So every intersection can have this level of data that's combining all of those data sources that we collect. One of the big ones that we see when you get to a network level is really being able to monitor that corridor progression, mapping out your major routes, mapping out what is the progression, where are the slowdowns, using travel time and signal information to understand coordination between our travel time charts and our time space diagrams. These allow us to line up not just the factors of detection input and signal operation, but how do all of the intersections connect together, and where is the network actually operating well, and where is it not, to apply the right level of attention to the problem. From there, we turn all of the data that we collect out of those charts and out of the metrics in a way that we call the report card. And there's probably a lot to digest here, but at a network, corridor, and intersection level, we've built report cards that allow you to simply take some of those data sets at each one of these levels and monitor how are they changing. Is it getting better? Is it getting worse? Is it evolving in any way? So that once again, we can help you look into that data and start addressing where to look when you have this many connected intersections. It kind of takes it takes away a little bit of that anxiety, so that you're not necessarily waiting for a problem to occur, then to go to look. It's trying to find the problems, or trying to find the opportunities for you, so that you're not necessarily looking for a needle in a stack of needles. The biggest piece of all of this that really helps you get to an outcome is what we call the intersection health tool. The intersection health tool takes in all of those data points, and it holistically evaluates each one of the intersections for you and looks for common problems in the network between detection operation, like phase interval or phase termination problems. Maybe it's suboptimal green splits and how well the intersections balance, or just the corridor progression problems. Where in the network are problems occurring, and surfacing that right up to you, so that you can turn that into an actionable outcome. So here's an example of a problem was identified at an intersection, and it pinpointed the exact movement and the exact data set that you need to look at to start assessing the problem. So this really gets you right into the heart of where to look and how to evaluate the data. Furthermore, into that, so I've been talking a little bit more about how we have the data, we collect the data, we measure the changes in it. We're also getting to this actual optimization platform. And I know this is a little video, I don't know how well it'll play here, but what optimization allows us to do is actually take all of that information and start surfacing up recommendations to you. Recommendations allow you to not necessarily assess all of the problems, but it really starts to dive into what could be the outcomes or the actionable things that you can do about those problems. We're starting with a corridor optimization. How do we align offsets? How do we align problems along the way and really improve a corridor overall? So this is a tool that is coming out shortly that we're going to have a lot of fun with, and it really allows us to complete the story of collecting the data, measuring the problems, and then turning those into outcomes. There we go. The last concepts of data that we have in here, which starts getting into the traffic safety side. When we're talking about safety, often we think about near miss or collision analysis and those types of outcomes. But really what we're starting with in our platform is taking all of the combined data sources, looking at safety and understanding compliance. So red light running being a common one. Where are the cars running red lights? How are they interacting with the intersection? How unsafe is this scenario? Even in the scenarios where there isn't an incident actually occurring, how do we actually look at that and assess the frequency of those problems, compare those to speeds of the roads or even volumes of pedestrians? And so you can combine those data sets to get a good sense of how severe is a red light running problem and where are the potential high risk impacts that may be occurring. So that's looking at the car side. When we think about safety, we also have to think about the pedestrians on the road. Who's in compliance? Are they crossing the road when they should? Are cars entering the intersection when they should? And how do we turn that into a compliance understanding of who's doing what they should be doing and who's not doing what they should be doing? And you may be intuitively leaping to this is the foundational components of near miss analysis and those types of applications. So you can tell we're headed in that direction of really understanding the behaviors, turning those into measurable items that we can see where are the highest risk scenarios, where are the problems potentially occurring, and then how do we apply countermeasures to those types of problems. So our platform ingests all of this type of information and turns them into a visibility of your network so that you can start really turning that into powerful outcomes. So with all that in mind, one of the biggest pieces that this takes us to is the power of the cloud platform. Having this in the cloud and utilizing a platform in this level of data, it allows us to constantly iterate. It allows us to build. It allows us to improve, collect more, integrate with other cloud technologies. So when we have all of this information in the network, we have all this connected information, what other layers of technology that are in the cloud as well can we connect together, because the cloud platforms allow for that? How do we securely and safely connect data points to make this more robust and more impactful? Between the power of AWS on the back end. This allows us to get pretty far into platform and cloud integration. So various types of tools that we've integrated in the past, we have a lot of good count data. So we integrate really well with MS2 now through our APIs and through our cloud platform. We integrate with video systems, we integrate with preemption systems, all because they're cloud-based technologies. And brokering between clouds is now safe and secure because of the level of security that the AWS group brings to us. Security is a major component of all of the architecture here, and that's why we trust in our AWS partners to make sure that we stay compliant to that security for your benefit as well as in a way that we can enable our partners to bring a platform and a level of network that you can actually add any application you want, including V2X and all the third-party technologies that you may be thinking about along the way. In a perfect world, our device has the power to actually just simply add these as applications to our devices, so you don't necessarily need to even add more hardware to your intersection. The cloud allows us to simply add their software to our hardware that already exists in the intersection. That's what really makes those devices that we were showing at the beginning really robust and really expandable, in the sense that between both operations, that platform is now in place that you can simply add these things and integrate more into it and connect those data points. In addition to all of that, that allows us to create a very raw feed of data from all of those sources. So open data APIs is a big core piece of this, and having API applications that you can integrate with that have all of the trend level data. You can look all the way back to where the data started. AWS allows for an unlimited expansion, it feels, where you can constantly collect data. You never have to worry about how much data or what storage you need and where all those servers may need to be. AWS takes care of all of that for us so that we can bring the power of data and the applications that you would like to use in our platform, as well as the APIs that allow you to have access to all of the raw data. And you can see here, there's a couple examples of trend level data between cars and trucks in the city of Detroit. How is the intersection operating throughout the day, and even turning it into peripheral applications like managing vaccine or testing centers throughout COVID here. So power of platform really allows you to make it what you need it to be and expand it to what you want it to be in the future as well. And so we've had a great time developing on top of the AWS platform, and it's really exciting to see the possibilities of the future. So with that, I'll end here and I'll pass it over to our good friend, Phil.
All right, so thanks, Brent and Kyle. Phil, at this point, if you can take over and share your screen.
I'm working on it. Let me just.
And in the meantime, let me just remind our attendees that I've posted a few links on the side in the chat box. If you're interested in following ITS Michigan, you can access us through our webpage or Twitter, YouTube, and LinkedIn. This session is being recorded and will be uploaded to YouTube also for later review. I've also seen a couple of questions come in. Please continue to have them come in. We will read them out, or you can ask them at the end of this session. Phil, if you're ready, back to you.
Sure. Just want to confirm that you are seeing the title screen and not my other screen that's got 100 things open on it. Are you?
Yes, I can see the titles.
Okay, that's great, because I don't want you to see the mess that is every other screen on my computer. I only really want you to see this one. Well, good afternoon, everybody. Thank you for allowing me to speak during this session. I got to tell you, I am so impressed with what Miovision has accomplished, and even more so what City of Detroit has accomplished with Miovision, and for the role that AWS has as a utility infrastructure provider in delivering that. While Kyle and Brett's presentation was at the 10,000 foot level, I'm going to step it up to about 30,000 feet. And for those of you who have a deep understanding of the cloud and AWS, you may find this a little redundant. But for those who really don't know what we are, this is our opportunity at a higher level to introduce how we are taking innovation and enabling companies like Miovision and public sector customers like the City of Detroit to innovate and build a new future. Within AWS, I lead the state and local government transportation vertical practice. And for us, that means supporting the agencies who are tasked with moving people or things safely, efficiently, economically, and equitably by working with customers and partners who recognize the power of cloud computing and how key it is to their future. So at AWS, this relates to our engagements with departments of transportation, traffic authorities, tollways, airports, seaports, municipal and regional planning organizations, and public transit agencies. And what I really just described there is a set of modes that operate in the Detroit region, and they tend to operate independently in silos. And one of the things that I took from the Miovision presentation is how it connects the dots between many intersections and then with other data providers. Well, we're also seeking to do the same thing, because truly a smart city emerges when all of those transportation modes can communicate with each other and the impact of one can be understood and accounted for in the other. So all of the transportation modes and operators and regulators that I described are also key stakeholders in the future of mobility and transportation. And every one of them face the challenge of modernization, resiliency, and cost savings, even as our transportation networks recover from the impacts of the COVID-19 pandemic. So what is the cloud? The term cloud computing refers to the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. So a very complex concept described literally in one sentence. And what it means for consumers of cloud utility is that instead of buying, owning, and maintaining your own data centers and servers, organizations can acquire technologies such as compute, power, storage, databases, and other services on an as-needed basis. And that's really relevant in an environment where usage is cyclical. As I'll describe further, instead of building for the maximum utility that you need Christmas Day at noon, the cloud enables, just like a power company where you flip a switch on to turn on lights in your home and the power company sends electricity. Well, the cloud works the same way for Detroit, Miovision, and all the other users of AWS. One of the main reasons that organizations around the world are choosing cloud is that it allows them, as you saw, to innovate faster. With the cloud, they can focus their highly valuable IT resources on developing applications that differentiate their business and transform customer experiences, instead of the undifferentiated heavy lifting of managing infrastructures and data centers. I don't know of many recent college graduates in computer science who are looking to do regression testing and to be formatting and changing hard drives. That in itself has become a commodity. They're really looking to work on higher end things that involve these tools, and we're glad to give them a mechanism to do that. Customers choose AWS over other providers because it has a lot more functionality, the largest and vibrant community of customers and partners, the most proven operational and security expertise, and is innovating at a faster velocity, especially in new areas such as machine learning and artificial intelligence, Internet of Things, and serverless computing. And you don't know it, but you saw an example of all of those things in the, well, maybe you do know it, but all of that was presented to you in what Miovision does. So we're very much focused on customers at AWS. And so I'd like to share the story of two AWS customers, Transurban and one of their solution providers, Veritol. For me, a toll agency or a transit agency or a traffic department or an airport or a Amazon fulfillment center, they all do roughly the same thing. They are responsible for moving something from one place to another through a maze, and to make it happen safely, efficiently, cleanly, and to bring technology to that. So as one of the world's largest toll road operators, everything that Transurban does works to get people where they want to go as quickly and safely as possible. From designing and building new roads to researching new vehicle and road safety technology. Sounds a little bit like the DPW. Transurban operates 20 roads in Australia and North America. They also have 6 major projects scheduled to be completed over the next few years. So they have a partner named Veritol that serves the tolling industry with breakthrough crowdsourced platforms and professional services like Miovision, all built on the AWS cloud. So let's take a look at a short video that demonstrates how the cloud has helped Transurban and Veritol innovate on behalf of their customers.
Phil, I believe the audio's not coming
Yeah,
through this time around.
Oh, okay. So we know we can make that
I know
work.
we tested it.
Of course it worked when we tested it.
Absolutely.
Just give me 1 second. We'll figure it out. Audio. Automatically ringtones, high fidelity music. I'm looking for the setting here. Start Zoom. Thank you for your patience while we figure this out, because this worked beautifully yesterday. Let me stop video for a second, because I think it's when you actually set it that video, audio. I'm looking for something that says audio settings. Audio. Automatically suppress background noise. Ringtones. Maybe it's in advanced. So I do not see. And I'm not going to waste your time. I will send you a link to the video so that you can actually watch it on your own. Can you explain why it works so beautifully? Yeah, can you explain why it worked so beautifully yesterday and not so beautifully today?
Sorry.
Take more, hold on. Hide names. I'm looking in more now. Share sound. Okay. Let's see if this works.
Hey.
Hey, Phil.
How's it
Yep,
going?
I
Great
can
to
hear
see
it
you.
now.
Nice car.
Yeah.
Only the best for my friends. Thanks for coming by today.
Thanks for having us.
Who does Transurban serve on the 495, 95, 395 express lanes around Washington, D.C.?
Our most frequent customers are two-parent households typically that work really hard and have kids, and so they're looking for additional tools to help give them time back. We have a new app called GoToll, which gives them the option to pay for tolls if they don't have an Easy Pass. And again, just lowers that barrier to using a toll road in the area.
And can you tell me how AWS helps enable Transurban's mission?
The technologies that AWS brings allows us to really focus on what we need to do by strengthening our community through transportation and transport. So we're able to focus on giving back to the communities that we serve, providing great on-road service, and
I'm sorry about that. What happened?
Hey.
Hey, Phil.
how's it going?
Around Washington, D.C.?
Our most frequent customers are two-parent households typically that work really hard and have kids, and so they're looking for additional tools to help give them time back. We have a new app called GoToll, which gives them the option to pay for tolls if they don't have an Easy Pass. And again, just lowers that barrier to the area.
And can you tell me how AWS helps enable Transurban's mission?
The technologies that AWS brings allows us to really focus on what we need to do by strengthening our community through transportation and transport. So we're able to focus on giving back to the communities that we serve, providing great on-road service, and continuing to innovate and provide new products and features for our customers.
That's really amazing. Joseph, can you tell me what Veritol has done to enable Transurban's work here?
Most recently, working with them not only on developing the 95 express lanes and a lot of technology you see there, but around customer digital channels that we've been migrating to the cloud for them over the last few years, and even developing new applications and new ways to do tolling.
Transurban's mission is to improve the communities it serves. Can you tell me a little bit about Veritol's mission?
Veritol is looking for simple solutions that help local communities and those that need it the most, all while serving state and local governments. One of those solutions that we like to focus on is our crowd toll solution, which will enable people to work their tolls or offset some of their costs of their tolls. And that's the thing about transportation, is it costs us all about the same, and it can disproportionately affect those that need it most. And we're really excited to be able to bring these types of win-win solutions to market with Transurban and AWS.
Spectacular. Thank you both very much.
Thank you, Phil.
So I think we could take the words Transurban and Veritol out of it and put City of Detroit Department of Public Works and Miovision and tell a very, very similar story. In fact, I have a vision for another one in this series called Traffic Jam, and maybe Kyle and Tony will actually record that in downtown Detroit. So what makes Veritol so special is their mission to use crowdsourcing technology to let mothers at home with small children, college students, and basically anyone with access to a mobile device earn some extra income or offset the cost of their tolls on their own schedule. In this area of work from home, this is a technology that is bound to expand in tolling and other markets and very well suited to being enabled by the cloud. Companies like Transurban and Veritol and many others are demonstrating the value of migrating traditional and on-premises computing platforms into an entirely new generation of built-for-cloud solutions. They're growing in popularity because they answer the key challenges faced by public agencies and authorities in this time. With the AWS cloud, they're able to modernize, increase resiliency, and reduce costs with an eye on what's important today and what is needed to sustain and serve their customers over the long haul, 10, 20 or more years in the future. And of course, their efforts also play a role in recovery, which is an important challenge that transportation agencies, authorities, and providers now face. So here's how. First, they are agile. They can quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. This means they can very quickly develop and roll out new applications, and development teams can experiment and innovate more quickly and frequently. They save on cost because with AWS, capital expense is traded for variable expense, and charges are only incurred as IT is consumed. Leveraging AWS's economies of scale, Dow Jones, for example, has estimated a global infrastructure savings of $100 million. They only provision what they need and don't have to over-provision to ensure that they have enough capacity to handle their business operations at the peak of activity. AWS manages and maintains the technology infrastructure in a secure environment. That means that companies like Miovision and their customers only provision and pay for the amount of resource they actually need, knowing they can instantly scale up or down along with the needs of their business, which also reduces costs and improves their ability to meet users' demands. They breathe innovation, and as stated earlier, are able to innovate faster because they can focus precious IT resources on differentiation, long-term planning, and transforming customer experiences instead of managing the upkeep, maintenance, upgrades, and refreshes to on-premises infrastructure and data centers. And finally, they can grow and scale globally with Amazon Web Services. With 24 launched regions, 77 availability zones, and over 217 points of presence, AWS customers can deploy cloud technology anywhere, anytime. So here are some other digital transformation examples. Elizabeth River Crossings operates under a 58-year P3 agreement with the Virginia Department of Transportation and committed to replacing its ailing legacy data infrastructure and hardware, working closely with its tolling support contractor. Modernizing its legacy infrastructure would allow ERC to avoid costly hardware refresh, improve its resiliency and business continuity capabilities, and enable it to better serve the thousands of drivers who travel its roads and tunnels daily. And we're proud to highlight what the city of Detroit has done every time I give this presentation, because the city of Detroit lowered its maintenance cost by 20% because it no longer had to dispatch personnel to check on the status of a signal. They cut travel times by 30% at a major intersection as part of their plan to mitigate $3 billion in annual congestion costs. And finally, improved emergency response times by almost 20%, an important safety goal achieved for this initiative. I'd like to say that the city of Detroit couldn't have done this amazing thing without the support of a technology provider like Miovision, and that Miovision couldn't have delivered all that innovation at pace and all the integrations and all those other capabilities without an infrastructure like AWS. There is a, I will stop my screen share now. And I do want to invite you at your convenience to take a look at the case study that we published on AWS about City of Detroit and Miovision's accomplishments. Tony, thank you.
Well, thank you very much, Phil, for presenting. And prior to that, Brent and Kyle, you guys kind of gave a really good overview of where we are. And I was trying to make it less about just focus about Detroit, and I think you guys did a pretty good job just to kind of show all these different solutions that are out there. But again, we greatly appreciate the opportunity that we have. We would not have been able to expand to this extent without the technology, the know-how, the teams that come with AWS and Miovision. So we do have a number of good questions. I'm going to probably read the questions that came in first. And then I'll open it up if anyone would like to kind of unmute themselves and ask their questions directly as well. So, and I will kind of also allow the people who ask their questions to do so. My mouse doesn't want to, oh, there it is. So the first question that came in was from Ted Sadler, and Ted asked the question that's on every person's mind right now. We're also trying to expand into that connected vehicle realm. Can Miovision's detection platform output to J2735 messages, either over DSRC or CV2X. For example, PED in the walkway against the light generates a pedestrian safety message alert to the vehicle. And I'm assuming this goes directly to Brent.
Yeah, I can answer that. Yeah, it's a great question. It's something we're thinking a lot about because of our high quality pedestrian detection and our ability to see the environment. So we've actually piloted this. We actually have attempted this in the city of Detroit, and we know our technology is capable of it. We still have some work to do on it to fully productize and integrate with more antenna types. It's a thing where we have in our development mindset. So we still have work to do, but it's definitely on our list of things that we want to be fully integrated in our product. And we've gone as far as piloting and showing that this is possible on our platform so far.
Right, and we were one of the first test locations for that. So great answer. There's also another question from Gary. Can this also be used for roundabouts, especially for turning movement counts at roundabouts?
It's a good question. I have seen it deployed at roundabouts, and there's two methods of counting with this system. One is the full turning movement count, where you see the full trajectories. And then there's the occupancy zones, or the count zones that you can do at each approach. Our configuration tool is a little bit limited to standard intersection design, standard four-way design at the moment. We do get away with some roundabouts. We haven't done a whole lot of them. I think I've seen 2 or 3 of them with this to get more approach count level information. It's not specifically designed for roundabouts at the moment, where our Scout product is. Our Scout product actually does a great job at detecting and counting roundabouts in a portable technology. On the permanent side, we often look for a permanent infrastructure, so like a signal, which isn't usually present at a roundabout. So we haven't had a whole lot of experience with the permanent installation version of our product, which is the SmartSense that we were showing today at a roundabout for that reason. But in terms of roundabouts in general, we have a lot of experience with counting and providing that data through our Scout product.
I just want to remind our attendees, if you guys would like to ask a question in person, just please mention that in the chat, or raise your hand, and I'll and unmute yourself and go ahead. We have one more question from Nat, and the question probably going towards Amazon. Any thoughts on how we can improve the resiliency of systems that are inherently reliant on monolithic system or de facto monopoly like AWS? It seems like there are a lot of economies of scale involved in such a large platform, but that there are similarly a lot of huge risks, whether in terms of switching costs, security, or reliability. I know you've hit on some of that, Phil, at some point, but would you like to kind of maybe answer that?
Sure, and we could take an entire afternoon answering that question. So Nat, thank you for that question. If it was easy, everybody would be doing it. There is a process that companies follow through on, particularly if they want to be successful on AWS, about how they move from their monolithic legacy systems, which when they were designed 20 years ago did exactly what they needed to do, but really aren't appropriate for the way we operate today. And I'll give you some quick examples. They're very hard to upgrade, right? Because they're so interdependent. Pieces connect to each other. If you want to remove one component, you're at risk of degrading the whole system. Whenever they're updated or upgraded, they have to go through a huge amount of regression testing in order to ensure that everything works. And they are very hard. It's very hard to add literally off-the-shelf capabilities like AI, ML, or building digital twins, or advanced analytics, or connecting them at the edge. IoT, very difficult to do because they simply weren't designed. And as many cities know, they're almost impossible to protect from a hack, right? Cybersecurity is just not their core. And the kinds of companies that are seeing the most success in the cloud and the AWS cloud are the ones who adopt a DevOps approach. And we have a whole team that helps organizations that have a legacy monolithic, not resilient in today's environment, data center running mission critical, things that really affect the lives of their citizens, how do you incrementally start to migrate that into a new environment that uses DevOps, that uses microservices and APIs instead of thick legacy APIs that can be built and expanded modularly. So like I said, there's a whole lot to unpack in your question, and we'd love to do it with you.
Great. Thanks, Phil. I appreciate that. We do have a couple more minutes. I do have a question for Kyle, but I do want to open it up to see if any of our attendees would like to ask any questions directly. Please feel free to unmute yourselves and ask. While you guys are probably considering that, Kyle, I have a quick question for you. And I know we're probably like a big client at City of Detroit. So, you know, when I need something, I lift up the phone, I give you a call. What has been your experience in terms of have smaller cities and smaller areas been reaching out for this technology? Is there benefit in just having one or two signals, or do you recommend having like a citywide or corridor-wide deployment?
That's a great question, Tony. So typically, what we see is when you look at the map of all of our customers spread across North America, you would see a majority of smaller agencies that have procured the Miovision system. One of the benefits of being a small agency is you have a limited number of intersections, and the rollout plan or the plan to deploy our system across a network is that much more realistic than, say, a Chicago or City of Detroit. The really unique feature of Miovision is our ability to be interoperable, you know, with the legacy systems, right? So at times I'll see lots that, you know, look at California, for instance. There's so many small cities of, call it 18 locations or 25 intersections, and they're the agencies that, you know, can look at us and out of box, you know, without upgrading their cabinets and controllers, they can have the ability with Miovision to get communications, to get signal performance measures, to get maintenance alerting, without doing, you know, the big plan of a fiber rollout or a cabinet and controller replacement. So yes, it is very important to kind of upgrade your aging infrastructure, but I am seeing an array of cities, you know, attach on to the ability to roll out quickly and get an array of solutions without, you know, worrying about multiple years of contract or construction scheduling. So yeah, I hope that answers your question. The majority of our customers, all are those small agencies. So thank you.
Excellent. Thanks. Well, I do want to do one last thing before I let you go. In 2 to 5 words, if we can just go down the list, just tell me what is the future for your technology, like whatever you think it is. Who wants to start?
I can start, Phil, just on the Miovision standpoint. The future of our technology is to continue investing into the computer vision aspect of our platform. We're seeing a very, very high demand for safety analytics and the ability to move pedestrians and multimodal aspects through the network safely. So I think that's one of our core competencies. The next thing that we're looking to do is drive optimization ability onto the platform, meaning we will serve up a suggested change or a suggested timing plan to allow the user, like Tony, to have the ability to deploy that plan and then track that plan. So yeah, optimization, computer vision, those are our 2 core focuses, I would believe, in the upcoming year.
Great.
So I can't do anything I can't do anything in I can't do anything in 2 to 5 words, but I can try 2 to 5 sentences. Look, we're on the precipice of perhaps really a historic time in our lives where we're finally going to address the physical infrastructure deficits that we as a nation have, and those infrastructure deficits won't be addressed fully unless we also address the IT infrastructure deficits, right? Both in understanding what we currently have, and, you know, drones are being used today to take pictures of bridges and identify where the weak points are using artificial intelligence and machine learning. And so I see both our physical infrastructure and our information technology infrastructure both being repaired in this process. And you play a very important role in making sure that happens. And the cloud will be here to encourage and enable that innovation.
Great, thanks, Phil. And I'm going to give Brent a chance as well. Do you want to do 2 to 5 words or 2 to 5 sentences?
Maybe 2 to 5 sentences. But yeah, I mean, my answer is kind of a combination of both there. The future of our products and platform is really that enablement of the platform. How do you do something once in a way that you can constantly add new applications, whether that be more Miovision optimization tools or integrating other technologies without the need for more hardware at the intersection. So how do you take that core horsepower that you have at your intersection and leverage that for more applications beyond even what Miovision provides, creating a platform level of use of the tools and the cloud applications so that you can save the most amount of money and create the most amount of outcomes at the same time.
Excellent. Thanks, gentlemen. I really appreciate it. So we did have one other question. It was regarding the API, and Duke was asking about 5G, and I can address those offline. And Austin, I'll reach out to you directly because we don't have public API. I'm not sure if any other agencies do. Kyle, Brent, do you want to take this real quickly at the end of the session? In terms of, are there any available public APIs for data collection?
Sure, I can answer that. So we do have an open data API available. The data is for each one of the agencies that's available is owned by the individual agency. So while the APIs exist, the keys to the data is managed by the individual city agencies. So if you do want access to those data sets, we help facilitate that through the agency so that they're aware of what data, who's getting access to it, and how it's being used. But we can facilitate the open data API alongside the agencies that have the data.
And I would add to that one other element. We do have a couple of federal projects coming up where part of the requirements for that grant is to have a public-facing data portal. So we are working on providing that, but that will be for limited parts of the city. Hopefully we can scale that up to kind of include more intersections. A lot of different cities have tried to do that, and it's proven to be successful. I think I read something about Toronto putting all their traffic signal information on there, so exciting stuff. Phil, if you don't mind, there was one more question. Can we still take that regarding the provide 5G or something similar? Is AWS in that realm, or do you just kind of receive you not communicate?
No, very much so. I mean, we're not a mobile network operator like Verizon or AT&T that actually build and maintain the 5G infrastructure, but we're very much about how quickly to move data from any location, including the edge of a roadway, into the cloud very quickly, and 5G enables that obviously at speed. I pointed Duck and stuck in the chat a link to AWS Wavelength, which is part of our 5G integration offering that any customer or partner, like either the city or Miovision, could avail themselves of as they take a look at, particularly in the world of connected and autonomous vehicles, how are we going to process at the edge as well as move that data into the cloud where it needs to be for all the other impacts we want to have citywide or region-wide.
All right, well, I just want to thank our 3 panelists here today for sharing your experiences and your technologies and all the great work that you guys are doing. Again, we appreciate the knowledge that you shared with us. I see that you had shared your contact information. I'll make sure I include that on our YouTube page where we will be uploading this video. Any last thoughts, questions? All right. Well, thanks again, everyone, and we'll see you at our next session in about a couple of weeks' time, a couple of months' time.
It's a privilege. Take care, everyone.
Thank you, everyone.